Hi guys, this is Faizan and welcome to today's session on data structures and algorithms in Java by Great Learning. So before I start, can you guys quickly confirm in the chat if I'm audible or not? If I'm looking on this side, that means I'm looking at your chat guys, so don't worry, okay? So quickly confirm in the chat section if I'm audible or not. Is everything okay? Can you see me? Can you see my screen? Can you see the pointer that is there? Okay. If everything is okay, just give me a quick confirmation. In the meanwhile, let me give you a quick tour of how our academy looks like. So go into the Google Chrome and type in Great Learning Academy. This is the first link, click on it and it will redirect you to this page. Herein you have all the courses available, right? Free courses, live sessions. You see, today is a live session on data structures and algorithms. Tomorrow or today itself, right? At 4 to 5, we have a session on how to create and machine learning engineer resume. Okay, so day after tomorrow there is machine learning algorithms, right? So we have popular courses also. Digital marketing is there. These are some popular free courses available. We have some courses in IT and software wherein we have Java, ethical hacking, cyber security, front end development, that is HTML and CSS, blockchain and all those things, right? We also have courses available in Hindi, that is Python programming, Python for machine learning, right? Java programming, C, React, R, AWS. All these courses are in Hindi. Okay, okay, great. I can see some yeses. Cool. So these are all the courses that are in Hindi, right? If you're looking for something that is paid courses, right? We have PG courses available. So you see, we have data science, we have artificial intelligence courses available in that. We have on cloud computing, cyber security, software development. So all these are paid courses. Okay, so do check them once the session is over. Okay, cool. With that being said, let's move on to our session and let's see what are the things that we are going to cover in this session. Okay, so first we are going to talk about what is Java, because we are going to implement these data structures and algorithms in Java. So we'll talk about Java a little bit, then we will talk about data structure, and then we will see array and its implementation. We'll talk about linked list and see how we can perform operations like addition, or inserting an element or deleting an element. Then we will talk about stacks, then we'll talk about queues, then some searching algorithms, and then sorting algorithms. Okay, cool. So now let's see. So what is Java? So the question is, what is Java? So Java is nothing but a programming language which is object oriented. That means it follows 4 pillars. What are those pillars? Encapsulation, inheritance, abstraction, and polymorphism. If you talk about encapsulation, what do you mean by this in a naive way, we can say that whenever we make classes, that means we are encapsulating all the data members and methods inside that class, so that we can apply some kind of access modifiers like private, public, and block their access to other classes, right? We have inheritance where we can reuse whatever is there in our parent class. That same things can be reused by its child class, right? Then we have abstraction, which means hiding unnecessary information. That is, sir, are the courses for college students having no, that those courses are also there, Vaishali. Okay, so polymorphism means to act differently. Okay, so polymorphism means to act differently on different inputs. Let's suppose the polymorphism is of 2 types. That one is runtime polymorphism, another is compile time polymorphism. Okay, so runtime polymorphism means overriding. That means you are overriding some existing method, right? That means if you have a parent class, obviously when we talk about inheritance, right, we have a parent class wherein you have a class, therein you have a method, and in that method, in the child class, you have that same method. That means you are overriding whatever was there in the parent class. Okay, so all these are 4 programming pillars that are present in Java. So obviously Java does not support multiple inheritance. Why? Because of its ambiguity, right? We know something that is known as diamond problem. That means whenever, let's suppose this is class A and we have 2 more classes B and C, and these 2 classes have a data member that is X, and now if class D is inheriting both B and C, that means we are doing multiple inheritance here. Okay, so here what happens, now this D is confused. Either he can go for this or this. He's confused. Should he go for the X that is present in this class, or should he go for the X that is present in this C class? So there is what is known as ambiguity, right? This is ambiguous in nature. So Java does not support multiple inheritance. It's a high level language, and it was originally developed by Sun Microsystem, and it follows the principle of Vora. That is what makes it different for other languages like C and C++. It is a platform independent language. That means if you write your code once, you can run it anywhere on a Java supported platform. Okay, that is what it makes it different from other languages. Those are not platform independent like C and C++. Okay, so this is what is Java in brief, right? Now let's see what is a data structure. So if you can see, there are two words in it: data and structure. So data means that arranging your data. So you are arranging your data in such a way that you can easily identify, okay, if this is the data structure that I have used, now what will be the time complexity? That means efficiency will be there, right? And you can create more efficient systems, right? And you can, obviously, when you have an algorithm in place, then you calculate its time complexity. You can move to more efficient algorithms with the help of data structures. That means how you store your data is very important. It helps you to identify the time complexity. That is, sir, checked yesterday, I couldn't find. Can you please tell me where I can find the engineering subjects? Sure, Vaishali, I will get back to you. Okay, don't worry. So when if it is a way to arrange your data in computers. Now you might be thinking, okay, so now we know that, okay, we are arranging our data in the computer. Okay, now we are storing our data, and now we can use some data structures. Now what are those data structures? We have linear data structures as well as non-linear data structures. Okay, so linear data structures are like arrays, linked lists, stacks, queues. Now you might be thinking, okay, sir, stack and queue are not linear. Yes, they follow some principle. That is, stack follows LIFO principle and queue follows FIFO principle. So those principles are there, but it falls under the same, wherein you have a linear kind of a structure. But yes, we there are some restrictions for stacks and queues. Okay, so these are all your linear data structures. Now we have non-linear data structures like trees and graphs. Okay, so this is whole in nutshell. This is your data structure. Now let's move on to our first data structure, that is an array. So what is an array? So it is a linear data structure, as we already have talked about it, right? So now what do you mean by this thing? That means if you have a memory location, right? This is, let's suppose this is your memory, and in your memory, obviously you will have some addresses. Let's suppose you have this space, you have 1 2 3 4 5. Now you have 5 bytes of memory available here, and 4 bytes of memory available here, and you want to store the 9 array of size 9. That means you are storing, you have 4 bytes here, 4 bytes here, 4 4 4 and 4 4 4. Okay, so you want to store an array with size 9. That means 9 into 4, that means you're talking about what, 36 bytes that you require. But you have 36 bytes available, right? Now I'm taking, for simplicity, I'm considering these addresses to be what, 101. Let's suppose this is 100, this is 104, this is 108. Okay, for simplicity, obviously these will be hexadecimal numbers, right? The addresses are stored always, the addresses are in the form of hexadecimal number. For simplicity, I'm taking it as an integer, that is 100, 104, 108 and so on. Okay, so now you have your 36 bytes available, but can you store an array of size 9? Is that this is the question for all of you. Can you quickly write in the chat, can you store an array? You have your you have what, you have the space available in your memory, but can you store it? Quickly just write it in the chat. Quickly answer this question, guys. I'm looking at your chat, and in the meanwhile, if I see anything that is relevant and you guys are asking, I will answer them. Okay, no. Okay, Z says no. Okay, no, we cannot, because we need for storing elements in the no, it should be linear. Yes, so it should be always contiguous memory allocation. That means one after the other, right? Elements are stored in a contiguous memory locations, right? And obviously now we cannot store it. Okay, sir, please repeat. So I was saying, Namrata, I was saying that if you have 36 bytes of memory available, can you store an array in your memory whose size is 9? That means 36 byte is the size that is required for this array to be stored in a memory location. But we cannot, because we have chunks of memory available here and there, but we need, in order to store an array, elements in an array, and we want to store, if this is our memory and we want to store this in this, we need contiguous memory allocation. Okay, so done. And you can access elements randomly using index. Now this is one of the properties of one of the advantages of using an array, that you can access directly with the help of its index, because we know that if you have an array, let's suppose you have this array and you have 1 2 3 4 5 6 7 and you have 0 1 2 3, these are all the indexes, so you can directly access this third element, which is at index 2. Okay, this is index 2, this is the index, and indexing always starts from 0. Why? Because if you see the name of the array, right, this is the name of the array, let's suppose the name of the array is ARR, right, and the name of the array represents its base address. Okay, this is one of the key points. Okay, represents its base address. Okay, now once you have a base address, now if I'm talking about this location ARR of 1, that means ARR of is the base address, right? Let's suppose the address of this is 100 and this is 104. So base address is 100, then we are plussing, then we are adding what? Adding 1 to it. That means we are moving to the next available memory, which is 104. So if I'm talking about this 1, that means I will always refer to the second element and not the first element. Now in order to access the first element, what you will do? You will do ARR of 0. Now if you do ARR of 0, which means 100 plus 0, which is always 100, and it will be your first element. Because now you understand why indexing starts from 0. Is this clear? Sir, can array be 3-dimensional? Yes, Malvin. Array can be multi-dimensional. Okay, you just have to add the subscripts. That means this is a 1D array, this is a 2D array, this is a 3D array, this is a 4D array. Okay, because it's static and more linear data structure. Okay, is this thing clear? Why array indexing starts from 0, right? So now we can access directly. This is done. Now we can store homogeneous. Homogeneous means similar elements. That means if you're talking about an integer array, that means you can only store integer elements. Okay, this is not that you can, sir, no sir, please repeat. Okay, Prashant, what I was saying, that array indexing always starts from 0. Now why does it start from 0? This is the you might be thinking. Okay, right? So you might be thinking, why indexing starts from 0? As I told you earlier, the name of the array, right? If this is the name, this is the array that is 10, 5, 6 and 20. This is your array, right? The name of the array represents its base address. Let's suppose this is the address 104, 108, 112. Obviously I'm taking, for simplicity, I am considering these addresses to be what? Integer numbers. But we know that it will, in the memory, it will be stored in terms of hexadecimal numbers, right? For simplicity, I'm taking 100. Okay, so and obviously now integer takes 4 bytes of memory, so that is why 100, then 104, then 108. Okay, so now name of the array represents its base address. Now if I'm talking about this element, what internally happens is it does this thing, 100 plus 1. Okay, this is the 1 index. Okay, this is the first element we are talking about, right? Index is 1. So if this is the case, that means we are adding 100 and we are moving to the next location. This is 1. That means we are talking about 4 bytes. Internally this thing happens, 104. That means we are accessing this location. Okay, internally this thing happens. Now this, had it not been starting with 1, right? Had it not been started with 0, we will always access the first element, second element, and not the first element. To access the first element, what we will do, we'll always start our indexing from 0. So that is why when we do ARR of 0, which means 100 plus 0, which is always 100, and it refers to this element. Okay, is this thing clear now, Prashant? So that is why indexing always starts from 0. Okay, now how can you declare an array? So we have data type and then the variable name and then the subscripts, right? So if you have data type int, and then you have variable then the name of the array, and then the subscript, and then new, which allocates memory, and then again the data type int, and then size. You will define size here, okay, the size of the element. Now you might be thinking, okay sir, we are defining a size, so there will be, okay, great. So now you might be thinking, okay sir, we are defining a size, that means we cannot exceed the, obviously, the size. Yes, that is one of the drawbacks of array, and we will get back to drawbacks once this slide is over, okay. So now you define your size, okay. So now what we have over here, right, we are declaring an array. This is the array declaration, and we can do it in two ways. You can either put it at front, right, or the subscripts can be at the back, okay. So these are the two ways you can declare an array, and you can initialize and declare an array in the same line, right. How you will put it arr and then the name of the array, and then the elements 1 2 3 4, these are the elements in the array, and that's it, okay. We are declaring and initializing an array in the same line. Now let's look at the advantages, right. This is the one of the most widely used advantage, is that random access is possible. That means you can randomly access elements with the help of, obviously, indexes, right. Easy sorting and iteration. Obviously, when you with the help of one for loop, right, you can iterate through the whole array, right. And similarly, you can sort it. We have some sorting algorithms in place, right, and we can use those sorting algorithms. Even if you don't have those sorting algorithms and you have no idea regarding those sorting algorithms, you can always use two loops and iterate through it, right, and compare one by one. Obviously, that will not be a better approach, but yeah, we can do it, right. So easy sorting is there. And replacement of multiple variables. Can anyone tell me what do you mean by this thing, the last step? How long will be this session? So this session will be for 1 hour. Okay, so if I'm going too quickly, if my pace is fast, do let me know in the chat, as these are some simple things, and we'll try to cover more advanced things as we move along. Okay, just quickly give me an answer for this third point, this advantage third, replacement of multiple variables. What does this mean? Quickly, guys. Okay, great. We don't have to declare multiple variables for sure. Okay, yes. Like we can replace variable name. No. Prashant, can you just rephrase the whatever you are saying? Changing any element at will. Okay. We need only one variable to store multiple variables. Yes, exactly, Vaishali. Yes. So do we have daily? Okay. Do you VB? Do you mean you have daily classes on data structures? No. This is one-off session on data structures. Okay. We'll try to cover as much as we can. Then I will tell you what is the next step at the end. Okay. This is just in prerequisites. We are going to release a video on data structures and algorithms. It will be a full course, and we will be implementing those things in C. Okay, and then obviously you can just move along with to different languages and implement those. Right? Only the implementation part will differ. If you are someone who's in love with Python, you can just implement it. Okay. Yes. No. It's a one-off session, right? Today is the only session on data structures and algorithms. Day after tomorrow, we will have a session on sorting algorithms. Okay. So don't worry. One by one, we'll try to cover different things. Okay. Okay. So now coming back to this replacement. So let's suppose I told you I need variables and I want to store roll numbers. Why C? Basically, only implementation will differ, since most of the guys start their coding in C, right? They try to learn C first. So C is the basic language, right? So that is why we are implementing it in C. But obviously, if you are someone who is interested in coding, right, like competitive coding, right? So therein you always go back and implement your data structures either in C++ or in Java. If you don't know any of these languages, I will prefer you should go for C++. But if you know Java, then Java is also good. Okay. The only difference between C++ and Java is that C++ is much more faster than Java. That is why most of the CP, that is competitive programming, is done in C++. Okay. So we can assign yes, Rishabh. So now what happens? So if I told you, okay, we have let's suppose I want to store a roll number. I want to store the roll number of 5 students, right? So what you will do int roll number 1, and then the roll number, int roll number 2, and then the roll number, int roll number 3, and then the roll number. Okay, so this time around I have only 5 students. Now what if I have 100 students? Are you going to do the same stuff for all those 100 students? What if we don't know C but only Java? Vaishali, in that case only the implementation part will differ. Okay, rest algorithms, implementation, leaving aside the implementation, algorithm, demonstration, analysis, that is time complexity, space complexity, number of comparisons, all those things are language independent. So you can, if you understand all those things with, along with some example, right? Example will be obviously dependent on the language, but apart from that, all those things are language agnostic, right? So they don't depend on language, so you can easily implement it in your language you are comfortable in. And soon we are going to release those as well in Java and Python and JavaScript. That is the plan. Okay, cool. So now what we will do, but what if I told you I want 100 students? Now what you will do, okay, you will just change, okay, you will just make an array of roll numbers, and you will declare its size as 5. Next time around, if my how much topic we are going to cover today. So I told you in the agenda, right, with the sorting, searching, we try to cover those things, right? And along with data structures, some data structures, arrays, stacks, queues, linked list. Okay, so now if I want to store 100 elements, right, or 100 students, I will just change the size. That is it, roll number and then 100. I don't need to declare all those int 1 2 3 4 and so on to 100. So it is a replacement of multiple values. Okay, variables. Let's look at the disadvantages, right? So obviously size is fixed, right? If size is 5, you cannot store more than 5. That is one of the disadvantages. It is difficult to insert and delete. Now what do you mean by this thing? If you have an array in place, right? Let's suppose you have this array in which you have 10 20 30 40 and 50, and you have 60 and you have one space left. I told you I want to store an element at this location. That means you need to swap all those elements. That means once you will be swapping them, you will have 20, this space is empty, you have 10, this space is empty. Okay, I don't think you can see it. So what happens? Now I will be swapping it, you have 10, you have space over here, and rest all the elements will be swapped by 1, and obviously the space should be there, right? Now in terms of deletion, now I told you I want to delete this element. Again, this reswapping of these elements is there, right? This more swapping is required, so it is difficult to insert and delete. Now what happens if your capacity is more? That means your capacity is 100, you can store 100 elements, but you're not storing 100 values, you're only storing 2 elements in it, so rest of the memory is wasted, right? So you're not using your memory efficiently. And always one of the major drawbacks is that needs contiguous memory allocation. At the start I asked you a simple question: what if you have 36 bytes of memory available? Can you store elements in the memory? Although you have 36 bytes, but those are available in chunks, right? And that is one of the major drawbacks of arrays. Even if if you have memory available, still you cannot allocate it. Okay, so that is going to be one of the major drawbacks. Okay, so now if we talk about applications, it is used wherein you require, or you want your application requires information to be stored in a linear fashion. It is suitable for application which requires frequent searching. We will talk about searching algorithms. You will see how easily we can easily search elements, like we have searching algorithms like linear search, binary search. So we can easily if you have an application wherein you require frequent searching, you can easily use arrays. Okay, done. And now let's see a simple demonstration, and then we will move on to the linked list, and we'll talk about the drawbacks that were there in the array and those were replaced by linked list. Okay, so now this is done, right? If you talk about this example, it is obviously we have defined a class, and I assume that you know how to define a class and all those things. So we'll go back straight into this part, right? So we declare our array int, and the array is price of pen. And if you don't know Java, you can always go back to our academy wherein we have courses available on Java. Okay, so that you guys can understand all those things. Okay, so we have courses available both in Hindi as well as in English. If and you will also get a certificate at the end. Okay, the completion certificate, obviously, right? So this is how you declare your array, and then you use a scanner class for storing the elements in this. You will use next int, and one by one you will be storing elements in this array, and finally you will be printing it with the help of single for loop. Okay, cool. So done. So now let's look at, now you might be thinking, okay sir, we have a lot of drawbacks to insert an element in the middle of the array. There is any built-in function like dynamic array? Jo Patnaik, okay. It say to insert an element in the middle of the array, is there any built-in function like dynamic array? No, in the arrays we don't have such kind of thing in Java, obviously. So for that, if you want to store any and you don't want to do the swapping, right, and you want to store elements at the middle, you want to insert an element at the middle of the array without doing all those swapping, for that same reason we have this data structure in place that is known as linked list. Okay, so what is a linked list? It is again a linear data structure just like array, but now if you have your chunks of memory available here and there, still you can store elements, right? Now those contiguous memory allocation, the drawback that was there, is replaced by linked list. Okay, now if you, even if you have chunks of memory, you can always store elements. Okay, elements can be stored as per memory availability. If memory is available, you can store, obviously. Now if you don't have memory at that time, you cannot store it, right? But if memory is available and those that memory is available in chunks, you can always store elements. Now you can access elements in a linear fashion. That means obviously now random access is not possible, right? So if you have this linked list in place, now you can access one by one. If you can access this element, then you can access this element, then you can access this element. Now direct access, that means if you want to go at this node or this linked list that is there, this list that is there, or this node that is there, directly, it is not possible. Okay, storing homogeneous elements, just like arrays, we can store similar elements. Okay, and it is dynamic in size. That means in arrays you have to define a size, right? You need to define a size, and then you can only store that many elements in that array. But that is not the case in linked list. You can store elements. Okay, you can store elements at will. That means if you have, let's suppose you are storing 3 elements, you can store 3 elements. You can, if you want to store 10 elements, you can store 10 elements. There is no dependency on size. Okay, done. So after that, one of the most important thing is that the starting node, that is the starting node, this node is the most important node in a linked list. Why? Because with the help of this starting node, you can traverse through the whole list. And if your head node, that is this node is known as head node. If your head node is lost, right? If your head node is lost, and let me give you an example, Shiny. Okay, so random access is not possible because you have chunks of memory available, right? And now when you have chunks of memory available, let me give you a naive example, right? Let's suppose you are in the class and you have, in the class you have 10 students and nobody knows where the other student is. But I told you, I went, now I have a starting point, right? Let's suppose Shiny is the first person and he knows the address of the next person, right? He knows the roll number of the next guy who is after him, right? Now this is the address part, this is the data part, that is Shiny, and this along with him I have given one more attribute that is there. That means that this Shiny knows the address of what? The next guy, that is Aditya. Okay, so now I went to him, right? I went to him and told him, where is Aditya? Okay, he told me Aditya is at this location. Okay, now I went to Aditya, I told him, Aditya, okay, where is Jyotsna? Okay, I went to Aditya, he told me, okay, Jyotsna is at this location. I went to Jyotsna and I told him, where is this guy? So one by one these guys knows the address and of the other person. Now if I went directly to Jyotsna, right, I cannot go directly to Jyotsna, right, because I only have the information of what? Shiny. So that is why there is a dependency, and that is the reason that random access is not possible. Okay, I know the address of only Aditya. Okay, this is my head node and where my linked list had started, that is from Shiny, and Shiny knows the address of Aditya. Aditya knows address of Jyotsna. Jyotsna knows address of XYZ. So there is a dependency, and I cannot go to someone which I don't know, right? I cannot go to Jyotsna because I don't have her address. So that is the reason that random access is not possible in terms of linked list. So you always need to traverse one by one. Okay. So now what are the advantages? Obviously dynamic size, right? You can store as many elements as you want. No wastage of memory, right? If you have three elements, there is no extra memory that you require. You only store three nodes, and it is easy to insert and delete elements. Now no more swapping is required. Let's suppose this is your list and you want to store one more node over here, right? Now you can only just have to break this link and just link this one node this to this. Okay, only one breakage of link is required. Now in terms of removing an element, let's suppose you have this place, these are the nodes, and you want to remove this element. Now you're directly going to link to that set. Okay, it doesn't matter whether you are you're in this node, that is the deleted node is still linked to it. We cannot access it, that means it has been deleted, and garbage collector will take care of this. Okay, so now this is easy insertion and deletion, efficient memory allocation, right? Obviously now we are using those chunks of memory that were there. So again we are dealing with such a scenario where we are using our memory efficiently, and we are allocating as much as memory we have, right? We have let's suppose we have 36 bytes. If we have memory allocation for those many elements, we will allocate them. Okay, done. These are the advantages. Now what are the disadvantages? As Shiny said, Cyber, can you rephrase I don't understand what you're saying. Sorry. So random access is possible, random access is not possible, as Shiny rightly said. Why it is not possible, I have explained, right? So random access is not possible. We always need to traverse the list one by one, because this guy knows the address of this guy knows the address of this guy, and I only know the address of this, that is your head node. Okay, so now we have a dependency on this head node. So for the same reason, if head node is lost, linked list is lost. Okay, these are the two disadvantages. Okay, now what about the applications? Okay, so suitable if you want to use your memory efficiently and you want to use your memory to its fullest, you always go for linked list. It is suitable for memory where memory is limited. It is suitable for applications where memory is limited. Okay, suitable for application which requires frequent insertion and deletion. Because why? Because we only require to break this single link for deletion and add one more link for insertion. That's it. Okay, Kashyap says A is equal to B. Yeah, transitive relationship, you can say that. Okay, so big O of n for random access. So now if you want to access all the elements, obviously you are traversing one by one to all the elements. So the time complexity in worst case will be now for traversing it will be always big O of n, right? Here I am reading you. Okay, cool, Cyber. Now what about let's try to see the demonstration or implementation. So you have this class and it is known as linked list node. Now I was talking about these structures, right? This is the one of the linked list, right? This is the node, right? In this node, right, we have created a class and we have named this linked list, right? And in this we have a data part and the next part stores the reference of this node, obviously, right? So this is our next and this is our data, right? So this is a structure of our node, right? And we have one constructor in place wherein we are just obviously whenever we create an object, and at that time constructor will be called and we are passing some data, right? So we will be creating a node like this, right, wherein we have, let's suppose we have this node over here, and in that node we have a data part and we have the next part. In the next part it will be null because it is not pointing to any node, right? So it will be always null whenever we create a new node. And in the data part, whatever we have sent here, let's suppose we have sent here 5 because we are talking about integer data type, and we have here 5. This is your new node that is created. Okay, cool. So now let's see how to insert an element at the beginning. Okay, so at the beginning, obviously now we have two cases. We always have two cases whenever we are dealing with linked list. What are those two cases? Now in this case, if we talk about insertion, right, we are trying to insert an element at the beginning. Okay, so the first case will be that you don't have any linked list, that there are no elements in the linked list, right? And the second case is that you have some elements, either it can be one or two or three. It does not depend on how many elements, it depends on whether you have or you don't have. Okay, in this case, let's suppose you have a single element, right? So now our program or this implementation or demonstration should hold for both of these. Okay, so now, as I told you earlier, the most important is this head node. Now this time around, it can either be null or it can have the address. Let's suppose you have a single node over here and this is our head node, right? And this, in this you have 5 and this is null, and obviously it will be having some address, right? Let's suppose it is having 1000. Okay, so this is your head node, right? So in first case, it can be either null or it can be 1000. Okay, reference. Okay, 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 no problem, no problem. Cool. So now what happens, over here, we have this head, it can be either null or it can be 100. Now we have this key, that is a new node that we want to create. Okay, so the key is, let's suppose we want to insert 10. Now whenever this step, that is the temp ttmp, we're creating a new node. You see the new keyword, now we are creating a new node, and at this point the constructor will be called and this key is sent. Now this ttmp is the new node, and in this we have a data part that is 10, and obviously with the help of constructor we have this null, and also we have some address or reference that is there with this node, that is 2000. Why this happens? Because of this constructor that we have over here, right? If you see that we have the data and we have then the next part, this is our data, this is our next part. Done. So this is our new node created. Now we check, either it can be null or it can be 1000. Now let's suppose we are taking into consideration where head is null, that means we don't have any nodes. Okay, we don't have any nodes, right? At that time head is null. Now what we are doing, we are pointing this head, that means this ttmp is our new head, because we don't have any new nodes, and that's it. This is inserting at beginning. Now we have a new node, that is this head node, that is this is pointing to this. This is what we did here, right? This head node is pointing to this 2000, right? And the else part will not be executed, and we are returning this head. If you see, the return type is of type ll node, that is linked list node. Okay, done, and we are returning. Now when let's suppose this is done, right? Now let me just erase some part of it. Now let's suppose we are calling this again, right? And this time around, right? You have a single node that is there, right? That is this node. Okay, right? So now you have this head node that is there. Now next time around, when this function is called again, this time around what will be head? It will be 2000. And what will be the key? The element that we want to store, let's suppose 20. Now this function, this statement will be executed, and a constructor will be called, and we will be creating a new node, that is ttmp, right? That temporary new node, and it contains 20 and it contains null. Why? Because of the constructor. And let's suppose 3000 is its address. Done. Now will this be executed? No, this time around. Why? Because we have 2000. Head is not null. This will not be executed. We will go into the else part. Now in else part, what we will do, we'll do whatever is in the temps next. What is in temps next? It is null. Please store head in it. Head is pointing to 2000, so we'll be storing 2000 in here, right? Done. And what is the next? Please point head to this ttmp. Now head is pointing to this, so this is not pointing to this node now. And now we have a link in place, that is this link. Okay, now if I write it in a better way, so this is your new node, this is your head, and it contains 20, and this contains 2000 in here. That is, this is pointing to this node, which is 2000, and this is your 3000, and this is your head node, and this is your 10, and this is your null. So why we are inserting it always at the beginning? Because we are implementing insertion at beginning. Okay, so we'll be always inserting our element at the beginning. Is this thing clear, guys? Quickly confirm in the chat. Is this thing clear? Do you want me to repeat this again? Is this thing clear? This is the most simple way I can explain you guys. Most simple. Quickly, just confirm. Okay, else part again. Okay, Prashant. I will explain the else part again. So now you understood how we came to this node. Let me just wait. You understood how we came to this part. How we and do you understood the first part? Okay. Okay. So do you guys understood the first part? Voltage. Okay. Do you understood the first part wherein I was just inserting a new node? Okay. So let me just clear it again. So we have now let's take case let's consider the case wherein we don't have any elements, right? So head will be null and we are trying to insert 10. Okay, cool. So now what happens over here in this step, we are creating a new TTMP and in this we have 10 and this is null. Why? Because of constructor. Done. And now this time around our head is null, right? Our head is null. So what we will do, we are just pointing this head to this TTMP. This is our new head and obviously this will have some address, that is 1000. So this is our new head. Now else part will not be executed and we are returning this. So now the next time around, now let me just erase this all, and now we have this 10 and which is null and this is our head, right? And obviously this will have some address, that is 1000. So next time around when we are calling this insert in at or in beginning, right? When we are calling this function, we are sending in head. Now this time around head is 1000 and the key, let's suppose key is 20 and we want to insert that. Now when this step will be executed, the constructor will be called and we have 20 and we have this null and this is 2000. Let's suppose this is the address and this is our TTMP, right? Now is this time around is head null? No, it is 1000. Right, head is 1000. You see, it is referring to this point. So this is 1000. So else part will not be executed. Now what we are doing, listen carefully. We are doing ttmp dot next. That is whatever is in this temps next, which is null. Please store head in it. Head is pointing to what? 1000. So it will replace this null by 1000. Okay, done. Now what happens in the next step? Now we are doing now this head. Please make this head point to this TTMP. So head is pointing to this. Okay. Let me just write it again. So head is pointing to this. Okay. Now what happens? We have a node that is in this way. Let me just clear. Now we have this 20, right? And this is pointing to 2000. Or this pointing to 1000, that is this node which is having an address of 2000, this is having an address of 2000, this is 10, this is null and this is our head. Okay, is this thing clear now? Cool. Now similarly we can insert at the end. Now every time when we want to insert the element at the end, we will traverse. So this is where this traversing happens. So we will traverse to the end, right? Will traverse one by one and at the end. Okay, is this thing clear? Do you want me to explain this or not? So that traversing happens over here. Similarly, we will have that case available wherein if no elements understood. Okay, great. So obviously we will have both these cases wherein you don't have any linked list and wherein you will be having some linked list. So this is the case wherein you don't have any list available. That time around you will have only one element which is at the end. Obviously you have single that can be at the start, that can be at the end. And now in the next case what happens, you will be traversing to the end and then inserting that element. Okay, so you will be traversing and that traversing will happen over here. Now the most important thing, can you guys quickly answer, do you change your head or you will use some temporary variable to store your head and then traverse that temporary node to the end? Quickly answer, yes or no. Will you use any temporary variable for storing your head, or you will change your new head? Quickly, I will just check if you have understood linked list or not. Will you change your head, or you will use a temporary node? Quickly, guys. Kashyap, Voltage, Prashant, Patnaik, Sundar. Quickly, guys. Will you change your head, or we will use two variables? Not a variable, yeah, but you can use a temporary. Yes, yes, Prashant, yes. Not a variable. Obviously, you will have a variable which is of type linked list node. Okay, yes. No need to change head. Yes. So you see the thing that I'm doing over here in this step. The thing that I'm doing in this step. This is the most important step. That if I'm changing the head, that means our head will be at new location, and now our linked list will be lost, right? So that is the reason every time when you are playing around with, okay, we will use a temporary variable. Okay, cool. So now every time when you are playing around with linked list, you will always use a temporary variable to change your what? To change your list. That's it. Okay, cool. To traverse, right? Every time we can we can. Yes, you need to change your approach then, right? Obviously, but that is not recommended every time, because then you're using any extra memory. Every time or you can keep a track of what? You can keep a track of a temporary. You can use one temporary node, and you can always keep a track of tail. So you will have two pointers. That is of type linked list node. Obviously, one is pointing to the head and one is pointing to the tail. Yes, you can do that, but now. Yes, you can use. You can use tail, obviously, so that you don't have to traverse, right? But you have to insert it in that way, right? Every time when you are inserting, your insert at beginning will also change. When you are inserting any node, you want to keep a track of that tail also, and you need to update that tail, so that every time your time complexity will reduce from big O of n to n, to constant amount of time, because you have tail in place. You just need to update the tail, right? Cool. So now what happens when you're inserting at any particular position, right? And this time around, I will be taking as one more argument, right? So taking in as one more argument, which is position. Okay. Irfan Sheikh says head is the first node. Yes, and you can also use, as Patnaik rightly said, you can also use a tail, so that you can have you can have in place the head and the tail of the linked list. That means if you have this linked list available, you can always have two pointers. One is pointing to the head and one is pointing to the tail. Well, that tail will take some extra memory. Uh, Obviously it will take, but it will have, you are only storing one node, so that can be considered as, that is not dependent on length of the node, right? Length of your linked list, right? So obviously you are storing one single node, and it is independent of whether you are having 10 elements or 20 elements in your list, whether you are having 5 elements. You are only storing a single node, so that is independent. So, and no extra memory. You cannot say that, okay, if you're using x variable, or if you're using int x, or if you're using linked list node element. So that is not, obviously you're not using any extra space. That will be considered as constant amount of space. Okay. So will stack and others will be covered today. Um, we only have 10 minutes, so let's see how much we can cover. Ayush, maybe in the next session we'll try, but uh, it will work like circular linked list. No, not circular linked list. Circular linked list is that, wherein you don't, obviously you have, let's suppose you have a linked list, and you only have one single pointer there, which is your head. You cannot just differentiate from head and tail. You don't have that. And those two linked lists are, you can traverse through them. That's a different case. It will not act like a circular linked list, but yeah, that's a whole different ball game. Okay, so now let's try to, you tried this out, the slide deck is shared with you guys. I will try to cover the stack as well. Okay, so let's move on to the stack. Okay, so you try to cover this thing. If you have any doubts, please write them in the comment section. If that thing is I will try to answer them. Okay, cool. Okay, so now let's try to cover stack as much as we can. Okay, so now stack is also a linear data structure, right? So obviously, but it follows some principle that is known as LIFO. That means last in first out. Let's suppose you have a stack of plates, right, one after other. Now obviously you can only have access to the top of this stack, right? Top of the this plate that is at the top, you can only have access to that. Now what do you mean by last in first out? Obviously the news, if new plate comes, it will be at the top, and it was the last element that was in, right? This was the last plate that was in, and it will be the first that will be out, because obviously when you want to access this third plate, now you will need to remove this one first, which was just entered, then you need to remove this, then you need to remove this, then you will be at the current location that you want to remove. So the last element that is in will be the first element that is out. Simple. Done. Now only the top of the element is available to you. Now this is a restriction that we apply on stacks and queues. Obviously queue will have a different kind of restriction, but on stack we only have access to what? The first element or top of the stack, right? And insertion and deletion will take place from that top. Done. Obviously if we talk about examples, you can see stack of plates, stack of chairs, and all those things, right? And it has four major operations: push, pop, is empty, and peek. All these operations. Push, that means you're pushing at the top of the stack, right? And you have your top pointer that is pointing to the top. You just need to update this top to top plus 1. This means push. And you want to remove, you're removing this. Now you will do top minus 1. You have top in place, right? Is empty, you will check if top is containing any value other than -1. That means if it is -1, it means empty. If it is not -1, it means that it contains element. Peek, you will just return whatever is in the top. That's it. You will not be removing it. You will just see, okay, this is the top of the stack, and you will be returning its value and not removing it. So if you observe carefully, all these operations are happening in a constant amount of time. Why? Because you have that top iterator, or you can say that you have that top pointer that is pointing to the top of the stack, and you're only manipulating this top in a single step or single unit of time. So that is the reason, and you need to always keep this thing in mind whether you are implementing stack either in arrays or in linked list. This property should hold, that your push, pop, is empty, peek should always be running in a constant amount of time, because that is the most important thing when you're using stack. Is this thing clear, guys? So whether you are implementing it in the form of arrays or in the form of linked list, you always need to implement it in constant amount of time. Let's see how. So let's talk about first advantages, and then we will talk about how. Okay, so it maintains LIFO manner, right? It maintains the last in first out order is maintained. Last element is readily available for use, right? The last element that is top of the stack is readily available, and all the operations that you can see, that all the operations, that is push, pop, peek, and is empty, all these operations were performed in constant amount of time. Okay, now what are the disadvantages? Obviously we have restricted, it is not much flexible, right? We have restricted our input and output in such a way that we only have access to the first element, right? And manipulation can be only done with the help of, sir, please will you cover nesting in future? Sure Malvin, sure, nesting will be covered. Okay, don't worry. So now what happens, the top of the stack manipulation can be done only on the top of the stack, right? And now if you talk about applications, if you have seen recursion, what happens internally stack has been used. Let's suppose, what is recursion? Function calling itself, right? Function calls itself. Now at here, then we are returning to which function? The function which recently got called. So this is pop, this is push, and then you are returning back. This is popping it out, we don't need it. Then you are returning to the previous, pop it out. Then you are returning to the previous, pop it out. So whenever you are using recursion internally, what you are using stacks. So you have to be careful whenever you are implementing or whenever you are doing competitive programming, right? CP, competitive coding, whenever you are doing these competitions, whether obviously or the face-to-face interview, every time an interview asks you whether you are using any extra memory, you have to be careful, okay? Until false function calls itself. Yes, the false function, you can say that, until the base case is reached, and then we will traverse back, right? Sir, is this the first lecture of data structure? Yes, Raghav, yes. So, what happens? You will be traversing back. And it also happens in passing. If anyone has any idea regarding automata, right? In automata you have some parse tree wherein you will be dividing your first you will be dividing your code into tokens, then a parse tree is formed wherein you will be performing your operations, addition, subtraction, right? At that passing also in that parsing also stack can be used, okay? Browsers, simple example, browsers, let's suppose you have your Google Chrome, right? In that Google Chrome you typed in Great Learning, you clicked on Great Learning, right? And you are in Great Learning page, right? And in Great Learning, okay, so in Great Learning, what you do, you go on to the courses that are available, free courses, right? And in that free courses, you are in the free courses and you have the number of courses, IT, software, IT and software, digital marketing, all those courses are available, right? And you click on one of them, right? Let's suppose your IT and software, you have your IT and software in place, right? And in that you picked on Java or C or C++, right? So you see now when you press back button, so this is what we are doing. So a stack is maintained, right? A stack is maintained. Now when you press back, will you go back to the Great Learning? No, you will go back to courses. You will go back to this will be popped out. You will go back to Great Learning. This will be popped out. You will go back to Google. This will be popped out. So it uses stack internally. What about the editors? The editors, whenever you are writing something, right? Let's suppose you're writing and now you want to go back to the previous step, redo and undo options, right? You have those redo and undo options, right? So all those things maintain stack internally, okay? Is this thing clear to you guys? The application where stacks is used, okay? So now let's see the demonstration and then we will end this session. I have many things to cover, but yeah, so it takes time, okay? Previous page, yes, exactly. So now if you see, we have a class stack in place and we are implementing it using arrays. Now what is your homework or what is that I want you to do is that implement it using linked list. You know the linked list, copy paste to, yes. So now what happens, you have an integer array wherein you will be storing all your elements, right? You have an array and you have this top iterator which is there. So these are the two data members and you have this constructor over here wherein you are declaring this size of the array as 100 and the top as -1, okay? So you have your array A place which is having size. Now obviously it will have some constraints. What constraints? The size will be fixed, right? And now if you don't want that constraint, that means if you don't want that size to be fixed, you can always go back to linked list wherein this size option will be removed, okay? So now what about this push function? Now whenever you call this push function, you will be sending some data, let's suppose 5. Now you will be checking if top is equal to array length -1. So why I'm using this -1? Because indexing starts from 0. So now if top is 99 and the size of the array is also 99, that is 100 -1, that is 99. That means all the elements in the array are stored. You don't have any space left in the array. That means overflow condition, okay? This means that you are exceeding the limit. This overflow condition is there due to the fact that you are implementing it using arrays. When you don't use arrays, you use linked list. At that time, this overflow condition will never be there. Okay, is this point clear to you guys? So overflow will not be there. Now, if this is not the case, then what you are doing? You are just incrementing your top. That means top is -1, and at start top was -1. You are pre-incrementing it. That means that top is 0. So ARR of 0, you are inserting your x, that is 5. So your first element is inserted. Okay, this is your push function. Now what about the pop function? Now let's suppose you are trying to insert something else. So now let's suppose you are using push function several times. Push 5, 10 and 15. Okay, so your top is here at index 0, 1, 2. So top is at 2. Okay, done. Now whatever let's suppose you are trying to remove the pop function that is there. You're trying to remove and you're returning something. That means whatever you have removed, you want to store that. Okay, you want to return that. That's it. So let's suppose your array is empty, that means top will be -1, and this is the case wherein this is the underflow condition. That means you don't have any elements and you're trying to remove something, which is not possible, right? That is your underflow condition, and it will be there either you are implementing it using arrays or you are implementing it using stacks. Okay, done. Now if that is not the case, at that time you will be returning, let's suppose if we talk about this case, at that time what you are doing, you're doing post decrement. Now this time around what you're doing, you're returning 15 and then you're decrementing your top. Okay, you're not removing it completely, you will be overriding it next time around. When you're using push, you will be overriding this 15 with the new value. Okay, that's it. So this is your pop, this is your push, and this is your display function wherein you are just displaying the elements in the array. Now what about the is empty? You will be checking only the value of top. If top is -1, that means you will be returning true, that means the stack is empty, else you will be returning false. What about peak? Peak is similar to pop, but only thing is that you will not be removing anything. Obviously when you're implementing it, you'll be using array, you might be arguing with it that we are overriding it, we are not still removing it. Yes, that will be the case, you are just overriding it. But in this case you will not be overriding it as well, the top will remain at its own position. So let's suppose you have this top over here and you have 5, 10 and 15, you have top in here, you will be just returning this, that's it. You see ARR of top, that is what is peak. Please go and check the top of the stack, which is this, right? This is the stack. Now you might be thinking I am writing in this way, it doesn't matter, right? Can we use null in place of -1? Yes, you can, because internally what happens, these integers will are converted into wrapper class. That means integer will be converted into its wrapper class, that is integer. Okay, so yes, it holds true for what? If you're using null. Okay guys, so this is it from this session. I hope you enjoyed this session, and maybe I will catch up with you guys in the next session. Until then, we will see what we can do in the next session. We'll be covering most of the top 5 sorting algorithms. Okay, so don't worry about it. Okay, so we will try to cover these rest of the things that were skipped in this session. Okay, cool. Alright guys, so if you have any questions, please post them in the chat. Else you can always comment right after the session is uploaded. You can comment and I will get back to your questions. Okay, I give you 2 home. Okay, cool. Not sure of when it will be, but yes, we will it will be notified to you guys either in the community post or on our YouTube channel. Okay, you can always go back and see the Great Learning Academy, right, wherein we have all the sessions that are there in this week and the next week. The sessions are uploaded quickly. Okay, you can always go back and check those and see what sessions are there. Okay, cool. Okay, thanks a lot guys. So there's any session to watch from the beginning. Irfan, yes, there are sessions available on Great Learning Academy. You just register on data structures and algorithms using Java. Register yourself, and therein you will have many things. Okay, most of the things will be covered in that tutorial. Okay, and you will also get a completion certificate as well. Okay, so please organize a live session on DSA in Python. Sure Kashyap. You just type in Irfan, you just type in on Google Chrome or any Internet Explorer that you have, any browser you have. So you just type in Great Learning Academy and just click on the first link, which I just showed you at the starting. Right, this is the link. I just type in Great Learning Academy, and then it will redirect you to this page. Right, you see I am using the stack property here. I'm just scrolling back, pressing back, and I just typed Great Learning Academy, and now I'm clicking on it. And therein you have all these courses. You see IT and software, and you see data structures and algorithms in Java. Just click on it and register yourself. That's it. Okay, cool. Thank you so much guys. Please if you haven't subscribed to our channel, do subscribe to our channel. Please make videos on DSA in Java. Sure, we will be soon releasing a video one by one. We will try to cover all the languages. Okay, thank you. Thank you guys. If you haven't subscribed to our channel, make sure you subscribe our channel, and I will see you in the next session. Okay. Thank you so much, guys. Take care.